Okay, girls, so now we're going to have a look at 2013. That's the last differential equation one I'm going to do. Okay, so 2010 part A is very straightforward. We're given an equation and we are told the limits, and we're just asked to find the value of y when x is 14. Okay, so the equation is x squared dy dx minus 7 equals 0. We know that y is 1 when x is 7, so I'm going to fill in that information into here. So I know that y is 1 when x is 7, and I want to find the value of y when x is 14. So I'm going to use limits then for this one to make it easier. Right, so the first thing I'm going to do is sort out this equation here. So this will become x squared dy dx. I'll take over the 7 over to the other side, and that will become equals 7. Just get a different pen. Okay, separate the variables. So this will become dy is equal to 7 over x squared dx. So this will be dy is equal to 7 by x to the minus 2 dx. And then I'll integrate both sides. 7, of course, is a constant. So the left-hand side, and I'm going to use limits again of y is going from 1, y is to 1. I'll just drop them around the other way. And x is going from 14 down to 7. Okay, so when I integrate the left-hand side, it just becomes y. And when I integrate the right-hand side, 7's a constant. So this becomes x to the minus 1 over minus 1. So y is equal to minus 1 minus 7 over x. And then I'm going to fill in, as I said, put in my limits. So y from y to 1 and x from 14 to 7. So when I do that, what will I get? This will become, do it over here. So this will be y minus 1 is equal to minus, I'll take out the minus, 7 over 14 minus 7 over 7. So this gives me y minus 1 equals minus 7 over 14, of course, will be a half minus 1, which will then be minus a half. So this is y minus 1 equals plus a half, so y is equal to 3 over 2, 1.5. So that's the first part, nice and straightforward. Now, the second bit, let's have a look at it. The second bit says, a particle starts from rest at time t is equal to 0. It travels along a straight line with this acceleration, 24t minus 16. T is measured from the instant the particle is at O. We've got to find the velocity and its distance from O when t is equal to 3. Okay, so we are told here, this is part 2, we are told that the acceleration is 24t minus 16. So I'm going to put that in here. A is equal to 24t minus 16. Question asks me to find the velocity and the distance from O when t is 3. Okay, so to find velocity, I'll change this a into v dv ds. Sorry, to find velocity, I'll change this a into dv dt. Equals 24t minus 16. Okay, so I've got to find, my limits are, find v when 3 seconds have passed by. So starting at rest and time at t equals 0, find velocity when t is equal to 3. And I've also got to find the distance again, starting at O, find the distance when t is equal to 3. Separate my variables over here. dv is equal to 24t minus 16 dt. Integrate both sides and put in my limits. Limits here going from v to 0 and 3 to 0 for my time. Okay, so this left-hand side becomes v is equal to 24t squared over 2 minus 16t. Put in those limits, so I'll get v minus 0 equals, that will go in 12 times 3 squared minus 16 times 3. That's my first set of limits, minus 0 for the second limit. And of course this will become, v is equal to 9 12 108 minus 48, so I get 60 meters per second for the velocity. So that's the first part. I've also got to find now the distance. Okay, so this time, where am I? So, okay, so this time I'm going to change my A. This is my A is 24t minus 16. I want to get distance, so I could change this into V dVds is equal to 24t minus 16. However, then I have three variables, t, v and s. So if I have three variables, then I can't do it. So I need to try something else. Okay, so in this case, I'm going to go back to my v expression. So go back to v. V is equal to, up here, 12t squared minus 16t. Okay, without any limits, if I didn't put in any limits at this stage, I would have had a plus constant of integration. Okay, so use the initial conditions to find your value of c. My initial conditions were that v was equal to 0 when t is equal to 0, so I'll put those initial conditions in here, which gives me 0 is equal to 0 plus c, so c is 0. So the equation I'm going to use is going to just be v is equal to 12t squared plus minus 16t, Okay, I'm getting swept down to another page. Right, so v is equal to 12t squared minus 16t. I want to find the distance when t is 3. Okay, so I'll change this v to ds dt, and then I'll have a distance and a time. So ds dt therefore is going to be equal to 12t squared minus 16t. I'll separate the variables. ds is equal to 12t squared minus 16t dt. I'll integrate both sides. This becomes 12t cubed over 3 minus 16t squared over 2. My limits, of course, s, where is it? S is going from 0 to s and t 0 to 3. So this will be s to 0, 3 to 0. So I'm looking for this from s to 0 and this from 3 to 0. Okay, so I'll put those values in, and this will give me s equals, that's going to be 4t cubed minus 8t squared. Put in those t values from 3 to 0, and I'll end up with s equals, putting in the 4 by 3 cubed minus 8 times 3 squared minus 0. That will give me 108 minus that's going to be, that's a 3 squared, that's 9872, and when I subtract that I get 36 meters. Okay, so the distance in 3 seconds is 36 meters. And then it says, the third part says, find the value of t when the speed of the particle is 80 meters per second. So all I'm doing here really is I'm changing the limits. So I want to find the value of t when v is 80. So it starts from rest, goes down to 80, and I want to find that corresponding v value. So I'll take that same equation again. V is equal to 12t squared minus 16t, and all I'm doing is changing the limits. So this time I'm just taking v from 80 to 0 and taking t from t to 0. And this will give me 80 minus 0 is equal to 12t squared minus 16t. So now I have a quadratic. I'll divide all the way across by 4. That'll give me 20 is equal to 3t squared minus 4t. So 3t squared minus 4t minus 20 is equal to 0. I'll solve that using quadratic, or whichever, if you're using guide and target, you solve using guide and target. 3t by t, factors of 20 are going to be 10 by 2, giving me a difference of 4, so they'll put the 10 here and the 2 there, that's going to be 6 2's. This of course will be minus and that will be plus. So when I put that equal to 0, I'll get t is equal to 10 over 3, t is equal to minus 2, of course it can't be this one, so my time is 10 over 3 seconds. Okay, so that's that part B. The last part of the question unusually this one was 3 parts of the question. There was a third bit, which is water flows from a tank at a rate proportional to the volume of water remaining. in the tank. The tank is initially full, and after 1 hour it is half full. So after how many more minutes will it be 1/5 full? Okay, so what do we have here? We've got a tank that is, and it says that this tank is emptying, flows from a tank, and the rate of it flowing, the rate is proportional to the volume remaining in the tank. So this is full, the volume of water is, so the rate that it leaves is proportional to the volume remaining. And of course, if water is leaving the tank, then the volume is decreasing. So the rate is proportional to minus V. Okay, if I've got this rate proportional sign, I'm going to get rid of this by putting in an equal sign and a constant. So a constant proportionality, that will become minus kV. And of course, the rate is the rate of change of volume. So this, of course, is dV dt is equal to minus kV. Okay, so question asks me to find how many more minutes will it be at 1/5 full. It takes an hour for it to be half full. So I'll use that information first of all. So I've got time and volume as my variables. At time 0 it's full, and after 1 hour it's half full. So I'll use that to help me find K. All right, I'll separate the variables. dV over V is equal to minus K dt. This becomes, when I integrate both sides, ln of V is equal to minus KT. Okay, and I'm going to put in my limits. My V is going from 1 to 1/2, and my T is going from 0 to 1. Okay, so when I put that in, what do I get? This becomes the ln of 1 minus the ln of 1/2 is equal to minus K from 0 minus 1. Okay, so ln of 1 is 0, so this is just minus the ln of 1/2 is equal to minus K by minus 1, which is just K. Right, now just something here over here at the side. Minus the ln of 1/2 is equal to, that's the same as the ln of 1/2 to the power of minus 1, which is also equal to the ln of 1 over 2 to the power of minus 1. So that all means the same thing here. And of course, if I brought that 2 above the line, that's the ln of 2. So minus the ln of 1/2 is the same as the ln of 2. That's just another way of writing it. It's a nice little link to remind us. Okay, now the next thing we want to find, we've got K. The question asks us to find how many more minutes before the tank will be 1/5 full. Okay, so now what is my dV dt? I can put in for K. dV dt is minus kV. And this time it's minus, K of course is minus the ln of 1/2, which is the same as the ln of 2. So this is minus, K is the ln of 2 by V. Okay, what do I want to find? I want to find out how long it takes for the tank to go from full to 1/5 full. And then I'll work out how much longer it takes to be from half full to 1/5. I'll do the last bit at the end. Okay, so separate the variables. This becomes dV over V is equal to minus the ln of 2 times dt. Okay, I'll integrate both sides. ln of 2, of course, is a constant, and I'm putting in limits from 1 to 1/5 and from 0 to t. So this will become the ln of V is equal to minus the ln of 2 times t, and then I'll put in my limits. This, remember, is going from 1 down to 1/5, and this is going from 0 to t. So this is the ln of 1 minus the ln of 1/5 is equal to minus the ln of 2 from 0 to the minus t. Of course, the ln of 1 is 0, so this is minus the ln of 1/5 is equal to the ln of 2 times t. Now remember, minus the ln of 1/5 would be the same as the ln of 5 is equal to the ln of 2 times t. So t is equal to the ln of 5 over the ln of 2, And when you work that out, you get 2.33 for your time. And of course that's in hours, so 2.33 hours. So just to finish off, it says, how many more minutes will it be 1/5 full? Okay, so it takes 1 hour to become half full. So 2.33 minus 1 is 1.33. So it takes an extra 1.33 hours. Extra hours. Now convert that to minutes. So 1 hour is 60 minutes. 0.33 hours is 19.8 minutes. So altogether that's 79.8 minutes. So it takes 79 minutes to the nearest minute, because it's not yet, it's more than 1/5 full then if you go past the 0.8. So it's 75 minutes extra. Another 75 minutes extra before it's 1/5 full.